Oh, man. All right, guys, let's take a look. So all of number 1 is the same. They all relate to the definition. What's the definition for every input, for every x? There can only be one output, y. Right? So this first guy, is there any input that goes to more than one output? No. 2 of them go to the same. I don't care. Right? So how many kids do you have? The 5th person says 3. The 6th person says 3. That's fine. They could both have 3 kids. Right? This is the one that's like the 5th person says, I got 3 kids. No, 2. No, 3. No, 2. Well, sometimes it's 3. And sometimes, no, you got... What's up with that 3rd kid? Well, it's like phasing in and out of reality. I don't want to see that shit. It's weird. So this is a function. No x has more than one y, or no input goes to more than one output. More than, you can do it, Jeff, one y. No x has more than one y. No x goes to more than one y. So this is not a function for exactly that reason. This has more than one output. Input 5 has 2 outputs. That's why it's a no. So when I give it to you in like this table form, domain range, it's almost like an XY table. It's a little bit different, but it's almost the same thing. You're looking for something that has 2 arrows coming off of it, right? That's really what you're looking for, because that would mean that one x has more than one output. In this notation, what are you looking for? Why? What's this? Is this a function or not?
No.
Why not? It's not. That's the correct answer. 9 goes to 1. And then this guy says, no, 9 goes to -5. It's like, what the shit? Where's 9 go? What are you doing? No. So this is not a function. 9 has more than one output. Oh my God. I forgot how to write. Okay. Did I ever know how to? I don't know. It's a good question. So what about this guy?
That's good.
It's good. I don't care that these go to -5. I don't care. 2 goes to one thing, 3 goes to one thing, 9 goes to one thing, all good. Yes. Function. No inputs have more than one output. Okay. Yes, sir.
So on the test we have to write the 9 has more than, otherwise we'll get blank out.
Yeah, if I say why or why not, you gotta answer that question. Yeah. So here you would say no x's have more than one y. You can say it like that. You could say no inputs go to more than one output. Yes, ma'am.
How is number, C and D different?
They totally are, because C says, what does C say 9 goes to? An input of 9. What's the output?
1
It says 1 and it says -5. That's like the 9th person saying, oh yeah, I've got $1,000 and I owe somebody $5,000. No. No, put that together. Tell me how much money you got. You can't, do you see what I'm saying? So 9 goes to more than one thing. That doesn't make physical sense. Yes?
Can you go back to A? That's a function.
Totally. Does any input, anything in the domain, go to more than one thing in the range? 5 goes to 3. 6 goes to 3. 8 goes to only 2. So everything in the domain goes to just one thing in the range. That's why this guy is not a function, because 5 goes to more than one thing. No? Yes? It's like I asked the 5th person, how many eggs did you eat this morning? And they're like, I ate 3 and 2. Did you eat 5? What the shit? How many eggs did you eat this morning? Give me one answer, bam. Right? Does that, you guys, that's the physical sense part of this. The function notation, the function definition is very intimately related to what makes physical sense. It's kind of nice. Hopefully. So in this representation, you're looking for that 2 arrows coming off. If you want a shortcut way to look at it, but that means that x goes to more than one y. Okay, I like it. Same thing over there, those are points. You look for any repeated x's, right? And this notation here, is there a repeated x? Yes. Is there a repeated x here? No. That's another little shortcut. Because again, if there's no repeated x, that means they each go to just one thing. If there is a repeated x, oh shit, it goes to more than one thing. Okay. These are all the same problem. Do the x's go to only one y? That's the question. Does each x have only one y? So in this one, what's the visual test? Same thing, same idea. What's the visual test? Somebody taught me it's called a pencil test, right? Or the pen test, whatever the hell you got. But yeah, if you can draw a vertical line and it hits more than once, that means that that x has more than one y. That's exactly, so they all are the same idea. If I draw a vertical line, that is an x value. Where's that output for this x value? There and there. That can't happen. No, yes. So this couldn't possibly be the graph of me throwing a ball or something. Because that would mean at this time, it was down here and up there at the same time. What the shit? Okay. Now, I'm not saying that a circle doesn't represent things. Don't get me wrong. But this is a nice way to kind of remember what functions are. They are kind of related to what makes physical sense. What about this guy? So this is a no. Fails vertical line test. What about this guy? Yeah, he's fine. There's no vertical line that goes through more than once. Yes, function. Holy crap. That's the word, yes. Yes. Passes vertical line test. So the vertical line test tells you if it's a function or not. Okay. You guys all right? Okay. What about this guy? I think the only funky one in this should have been E, but all of these are just plug and chug stuff. Where do I put -1? For which guy? For the F, I love it. So F of -1 would equal 2 times -1 minus 1. So F of -1 equals -3. Cool. So what's H of 3? I put a 3 in here. 3 squared minus 1. 9 minus 1? 8. So what does that mean? This would go through the point what? So H, this function, if I graph it, it will go through the point 3, 8. I didn't ask you to graph it. I'm just asking you, this is how I can interpret what this says. So what about G of 1? Yeah, I put it in here. So 1 minus 1 and down here. 1 plus 5, 0 divided by 6, which is? 0. I love it. And since h of x is x squared minus 1, h of m has to be m squared minus 1. You just take what's there and put it. It really is just substitution. That's really what it is. Finally, this guy. So the domain is the collection of all the values I'm allowed to put in for x. Domain is related to the inputs. So the way to answer that question for most things, for most functions, is what am I not allowed to use? And I'll say it's everything else. So for G, what cannot happen in this kind of a thing? I've got a top and a bottom.
You can't have 0.
You can't have 0 on the bottom. And what would make the bottom 0? And watch this, watch this. Let me say it in English, which is just bottom can't be 0. Right? That's what we're saying, right? It's not good enough for an answer. What is the bottom? X plus 5. How do I write can't be in math? See if anybody sees this. Yeah, not equal to 0. Solve this. X cannot be -5. Bam. Or you can say everything except -5. That is how every domain question of a function works. You say in English what can't happen or what must happen. Write down what you just said in Mathish and solve it. We're going to see that when we learn freakier functions later. Okay. All right, now watch this, watch. Come back up here. What does this work up here for 2a? What does this mean? The f goes through the point what? -1, -3. So if I were to start to graph it, I would go to -1, -3, and what would I put there? A point. I love it. Now, I have a point to this. What must f of -1 have been for this? Where did they put the point? There. -3. I don't even know what f is, but I know something better. I know all the flippin' answers to it. That's what the graph is all the answers. So you're like, there's nothing I could put a -1 in for, Jeff. You didn't tell me what f was. No, but I showed you the answers. What must the answer have been when x is -1? Well, it must have been -3, because that's where they put the point. So what's f of 2? 6, right? So forth. What's f of 0? -2. I love it. So whatever this function was, if they made an xy table of values, when they put a -1 in, they must have got a -3 out, because that's where there's a point. Okay. What about, remind me, domain is related to... Oh,
Wait, so f of anything is x pretty much? Like anything in little parentheses after the function is going to be on the x-axis?
that's going to be my input.
Oh.
And, and normally this axis is going to be x, but it could be t for time. And this could be velocity, for example. It doesn't always have to be x and y. So here my input would be t. So my domain would relate to what times I'm allowed to use, right? Does that sort of make sense? So your input is this axis. It doesn't always have to be x, but a lot of the time it's going to be x. I like it. Output is this axis. So domain is related to the x part, this axis. What's the smallest x that's used? 0 is used, but there's some stuff that's smaller. -3 has an output. So the domain is all the inputs that were used. Did I use -4? No, there's nothing there for it. So I didn't use it. So the domain would be from -3 up to 2, because that's the last thing I used that had an actual output. So domain is, if you walk along the x-axis, where do you see the function from -3 to 2? Range is the same thing, but it's on the y-axis, because range is the outputs. So range would be, what's the smallest output? -2 is definitely small, but then you go lower?
Oh, -2.
Yeah, so from -3 up to 6. Whoa. Yes?
Are brackets and then like those like fancy brackets the same thing?
No.
Okay.
These are set notation. Like I can do individual numbers. That would be the set of 1, 2, and 4. Interval notation is every number between this and this.
Oh.
Yeah. Unlock it. Okay. So any questions off of this guy? You'll notice a lot of similar stuff on the practice test from this. Okay, so now it's wide open. Whatever you guys want to focus on. If you want to do more problems like what we just did. Any specific things from the practice test, homework? Yeah. Oh, sure. Say again? This one here?
Yes.
This is on the practice test, 4B. So what two things do I need for the equation of a line?
Slope and line.
Slope and a point. Right, so I need the slope and I need a point. What do I have? What do they tell me?
You have a slope of 4.
Well, that I got to do some work. What did they just tell me? Yeah. So I know it goes to the point 9, -2. What's up?
May I have one? I didn't do one.
Yeah, go ahead.
Practice.
Sure. Is everybody with me? So I try to get students to, all right, let me say this. The people that are the best at math are the people that naturally break things into parts. I feel so bad for the people that think there's one problem and you attack the entire thing. It's like with word problems, you're like, I have to be able to write the equation immediately. No, that's insane. You break it down into parts. So I was lucky. I kind of look at things that way naturally, and that's why I was able to do math really well. So if you have trouble kind of doing that, that sucks, because that's kind of like a life skill to have. Break things into smaller parts, it's more manageable. So I try to get people to realize, if I ask you find the equation of the line that does shit, you write slope point. You break up your work. What do you need?
Practice. Thanks.
So I got the point checked. Now I can focus all my attention on figuring out the slope. And what do I know that helps me get the slope? It's perpendicular to this dude. So what do I have to know about this dude first? And can I see the slope right now? Not really. What do I have to do? Yeah, like you said, solve for y. So I get y equals -4x plus 2. Not 4x minus 2. So what's this guy's slope? So what's my slope? 1 over 4. I love it. Change the sign and flip it because it's perpendicular. If I would have said parallel, then my slope would have been -4, the same slope. Now what equation am I going to use? I used to say this, once you get both of these, you're at the SDT level. Same damn thing. You plug it into the equation and simplify it, right? So what y minus what?
-2.
Good, that's the y piece. Equals,
-4.
careful.
1 over 4.
Yeah, our slope is 1/4. X minus 9. And then you simplify that, right? You can, this becomes y plus 2. This distributes, become 1/4 x minus 9/4. Then you got to subtract 2, get LCD. The rest of it is just cleanup. Right, now you can subtract 2, make an LCD. So you end up with 1/4 x, -9 minus 8. -9 minus 8.
No, negative.
Yes.
Wait, so you can't just, so you can't just take the slope and make it perpendicular and just put -2? Like, if I were to get y equals 1/4 x minus 2?
Oh, no. How many perpendicular lines exist to this line? How many lines are perpendicular to this line? Infinite number. How many things are perpendicular to my pen? Infinite number. Holy shit. Right? So this keeps going forever. There's an infinite number of things that are perpendicular to it. Same thing with parallels, an infinite number of things. So the point that I give you actually identifies which of those I'm talking about. So there's an infinite number of lines that are perpendicular, but only one of those goes through that point. So when you plug that in, that's what you figure out, is which equation am I talking about. Yeah, so to do -9/4 minus 2, I have got to make LCD. Right, so multiply top and bottom by 4, so it has the same denominator.
Why you kept not the 9?
Why, what? Because it's already got a 4.
Cancel it out.
Didn't. What's negative 9? Yeah, I was trying. It's not cancel out, it's just poorly written. Negative 9 minus 8 is negative 17. Let me see. Sure, easier. So if I get to the point, so is everybody cool right here? This is where I just plug stuff in, right? So let me pick it up from right there. So this is y plus 2. Is that cool? Distribute the 1/4. Okay. And then I subtract 2. I can't subtract these because it's not LCD. Multiply by 4, so I get y is 1/4 x minus 9/4 minus 8/4. And negative 9/4 minus 8/4 is negative 17/4. Okay. So that's just cleanup. That should not be. Okay. All right. Yes.
Can we go over 6B, sorry?
Which one? Sorry.
6B.
Oh, so you did 6A, okay?
Yeah.
So this is the one we have to solve by graphing. So what do you have to do first with these two? Put them in their form, I like it. So if you haven't done this one yet, go ahead and try to do this one. A real quick word, if any of you think that you'll be okay in this class if you only work on math while you're in the class, you're insane, right? You got to do the homework. You more than likely need to get some help with some of them. There's all kinds of help on the campus. There's tutors in 2 different places, 3 different places if you have any accommodations through the ARC. Then you got me. Right? I'd be expensive as shit if you got me through Craigslist, but I'm free as all hell into my office hours. Yes?
On the YouTube, how do you title them? Do you title them by sections or?
I don't know. When I remember to title them, I try to title them by either section or idea. I don't always remember to title. All right? And you really can't say anything because that's just my way of trying to help you. I love when I get comments from people that aren't in my class. I can't really tell you. I don't care. You're not my student. I'm not Khan Academy. No, I'm not Khan. If you ever seen Khan Academy's only hands. Hello. Khan. So you should be getting these two when you're solving for y. So there you would add 4x divided by 3. Here you would divide by negative 6. What do you notice about both of these lines? Same slope. So they're going to not have one answer. They're either going to have no answers or infinite answers, but their y-intercepts are different. So they're never going to meet. Yes? So if you divide by negative 6, what's 12 divided by negative 6? Cool. I like it. If you add 4x over and then divide by 3, 3 divided by 3 is 1. So when you divide both sides, you have to divide both sides. You don't get to... So right here, on the first one, when you add the 4x over, you get this. Then you divide by 3. which means you divide this whole side by 3. Totally. I love it. But they don't cancel to 0. 3 divided by 3 is 1. So be careful. When you do this, you're not left with nothing. You're left with 1. Yeah. Well, the only way to get 0 is to subtract the dude away. You can't divide and get 0. You can't take a number. What do I divide 7 by to make it 0?
0.
You can't. 7 divided by 0 is the opposite of 0. It's infinity. Right? What do I divide by 7 by to make it equal 0? Can't. Do you guys understand what I'm saying? I can divide 7 by any number you can imagine. It's not going to equal 0. 7 divided by 1,000,000,000 still ain't 0. Stupid small, but it's not 0. I love you guys. The only way to make a fraction 0 is at the top start off as 0. Right? This is 7. It ain't never going to be 0. Okay. So if I graph these, that's this one. How do I go from here? Up 4, over 3, connect the dots. This guy's going to start at -2, and I'm going to go up 4 over 3, connect the dots. So what's the answer? No solution. They never meet. The answer is where they meet. They don't meet. No solution. However you want to write it. They never meet, so there's no answer. Okay.
Can you do A for that too, or no? Just the equation part?
Yeah, so the only one I've got to clean up is this first dude, right? The second dude's already in the right form. So here, if I subtract x and divide by 2, I get -1/2 x plus 6. Okay. I will pretty much be assuming we can solve this. So if I subtract x, I get there, right? And now I have to just divide by 2. Cool. Now the one thing that's a little bit rough about this problem is, what's the y-intercept of this guy? 0.6. So you can just make your scale different so it'll fit if you want to. Right? So what kind of scale do I don't want it 1, 2, 3, 4, 5, because then 6 ain't on there. Yeah, so I could do 2, 4, 6, 8, 10. Now this way, I can still do 1, 2, 3. Cool. And now I can just graph them and see where they meet. Yes?
Either way, like, I don't know, that's right, too, because we have the y, and the y, so we just plug it in there.
You got the what now? Sorry?
So we have 2x plus y, 2x plus 1, I mean.
Sure.
Take this one and then put it in there.
If only I said to solve it using algebra, but I say to solve it using graphing. But notice that the same problem shows up here. Yeah.
Okay.
So if you don't do what I say, even if you do everything right, you're just going to lose all the points because you didn't do what I said. Not just because you didn't do what I said, but because there's a reason I'm asking. Got to make sure you can do this. So if you don't do it, you lost points for that idea. Okay. So think what you want of me. I don't care. There's a method to my madness. Yes?
For 3b.
Wait. We're not done with this one.
Sorry.
So the second guy, y-intercept like you said, 0.6, and what's the slope? Now watch, this is how you got to be careful when you have a different scale. Down 1 over 2. Down 1 over 2. Down 1. And I'm off, right? Because down 1 would be from 6 to 5, and then 5 to 4. So when you change your scale, you got to be careful about how you count. Because now it's by 2s. You can't go down 1, you just went down 2. So there's that line. What do you know about this other line here? What's his y-intercept? 1, 0, 1. And it says to go up 1, 2 over 1. Up 1, 2 over, yay. Now what point is this? 2, 5. I love it. All right, so you can put 2, 5. Bam! That's the answer. And now you know ahead of time what the answer to this should be. Same problem. Just different way to solve it.
So B is y-intercept and mx is slope.
M is slope, yeah.
Okay.
Yeah.
You have to choose the, like the scale, otherwise we'll get marked wrong if you put it, if you don't do.
Well, I mean, if you don't pick the right scale, you might not be able to count correctly if you're going off the graph. Yeah. So part of what you have to learn in this class is how to pick the right scale. Here.
Could you just repeat the second line, how you did it?
Oh, this here?
Yeah.
Just, yeah, on the graph.
All right. So here's 0, 1. And then what's the slope say to do? Go up 1, 2 over 1. Up 1, 2 over 1.
Okay.
Because again, my scale is by 2s. So I can't say go up 1. Oh, that's actually up 2 because my scale is by 2s. Yes?
So I just I like added a like line like on top of the graph for the 6. Is that okay since there's only 1, or do I have to like change the scale?
Part of what I'm going to be checking for is the ability to pick a good scale.
Okay. So you
And
prefer the
if this was 14, that wouldn't be so good. Yeah. I like it. Yes?
For the 2x, the 2, yeah, so you put the 1 under.
Well, there is a 1 under.
Okay, I thought it went on top.
Well, no, then 2 would equal 1/2. You see what I mean? Yeah. Okay. So that's definitely up 2 over 1. Yeah. Okay. Yes?
Number 10F.
10?
F.
F. Oh, yeah. So this is almost the same exact question as the one on that other worksheet. What would freak G out this time? So the answer for the domain would be all numbers except -4, yeah. Become a C in there. Okay. All numbers except -4. That's what that's trying to say. Because what happens when x is -4? This becomes undefined. So I can't use -4.
Are one of those going to be on the test?
Yes.
And like, would a correct answer also be like the x and then all values such that x does not equal that number?
Oh, yeah, sure. Yeah. Another way to say this is x not equal to -4. And then the ultimate technical way to say this is -infinity to -4 or -4 to infinity. Oh, my God. If you want interval notation, but I'm not going to require that.
So any of those two answers that you have is.
This one,
and
this one, that's great. And this is a third option, but they all say the same thing, so. Okay. Yes?
3B. Do we just plug in like a 0 for x and 0 for
Yeah, how... So I can't remember if I told you the story, but when I took my last math class, Math 696, we had equations with about 11 variables in them. But if I wanted to figure out the W-intercept, what did I do? I made all the other variables 0. This idea never changes. If I want the X-intercept, I make Y0. If I want the Y-intercept, I make X0. Why? Why do I do that shit? Because Jeff said so. No. What's true, if there's a point, that is the X-intercept. That's the X-intercept, right? What's true about the Y value there? What point is this? What point is this?
-2.
No.
0, -2.
No. -2, 0. What point is this? That's another X-intercept, right? What point is that? 4, 0. What seems to always be true about X-intercepts? Y is 0 for an X-intercept. So how do you find an X-intercept? you make y 0. That forces you to be on the x-axis. Don't go up or down any. Go up and down 0. That's what y controls up and down. So I'm going to figure out where it is on the x-axis then. So for this problem, the x-intercept, make y 0. Whoa, shit, there it is. You see, make y 0. So replace y with 0. Now solve for x. What do you get? So what's the x-intercept? 3, 0. I love it. And for the y-intercept, you make x 0. You're not going to get a pretty answer, but you're not going to care because you'll be done with it when you get it. So how do you always find the x-intercept? You make the other letter 0. And we only got one other letter, so we make y 0. I get the y-intercept, make x 0. It's crazy. It's beautiful. Solving for y here is not going to help you too much. But you will find the y-intercept, but you will find the slope you don't need, and you won't find anything about the x-intercept. So it's sort of like you don't want to go that way. You don't care about the slope for this problem.
So you don't really got to divide it, you can leave it as a fraction?
Totally. Yes. So you're going to get, for the y-intercept, you're going to get 0, 6 over 11.
Right.
Beautiful. Leave it like that. I don't want to see that ugly, never-ending fraction. I mean, decimal. I'd rather have it as a fraction. That's the right answer. Yes?
C is just plus 8.
Yeah, but then what's the y-intercept? Yeah, when x is 0, what's y? Well, y is always 8. How about the x-intercept? What do you have to do to get the x-intercept? You have to make y 0. But what is y always? 8. So is there an x-intercept? No. In fact, what kind of a line is this? Y equals 8. What kind of a line is it? Horizontal. And that is parallel to the x-axis. So we'll never hit the x-axis. No x-intercept. So those special cases will have one of the intercepts won't exist. Sorry.
So for that answer, how would we write it? Put x.
Oh, so you just say the y-intercept 0, 8, x-intercept none. Yeah. You'll see. I have a answer key. Just to remind you guys. I'll give you. Yes.
So if you just get like the x or just the y, can you plug that back in and get the answer that way?
No. No. So here, if you got the x-intercept 3, 0, how would you use that to get the y-intercept?
Like if you plugged it back in for x.
If you plug a 3 in for x, what are you going to definitely get for y? 0. Or you know that 3 becomes 0. I really want you to see that. When I find a point 3, 0, that means when I plug a 3 in, I get 0 out. Right? So you can't use one intercept to figure out the other one. How do I find the y-intercept for this guy? I make x 0. The minute x is not 0, am I still on the y-axis? If x is not 0, if x is 1, am I on the y-axis? No. So what does x have to be to make me be on the y-axis? 0. X has to be 0, and then I'm on the y-axis. That is why I make x 0 to find the y-intercept. Because that's where I'm going to be. I always like to think of it like I'm making the equation. Tell me what the y-intercept is. Psh, psh. Right? Put the x in there. Tell me. Oh, that's just me. Yes?
Can we do number 5?
See, there's one that I've written all over. Okay. So rate of change. I cannot just take 72 divided by 7. That doesn't make any sense. Rate of change. What's another name for rate of change? Slope. So really all you're doing is find the slope. So at 7 a.m. it was 72 degrees. and 9:30 is 77 degrees. Temperature per hour. So how much did the temperature change?
5 degrees.
77 minus 72, right? So 5 degrees. And how much did the time change? Yeah, 2.5 hours. And now just reduce that. Just divide that.
When we write that answer, do you want us to write it out like 2 degrees?
You better put the units, yeah.
Well, because like, I wrote it on the homework as like, one of those questions I wrote like 2 degrees over hour. And you made a mark on it. So should I write it out just 2 degrees per hour?
I don't know what happened. So you should read the instructions again. Something went wrong. I didn't mark it out because you put units. I'm going to mark it out if you don't put units.
Okay.
But make sure it wasn't minutes or something. I don't know. Something else went wrong with that one. So this will be 2. This will be 2 degrees per hour. Right, 5 divided by 2.5. Okay.
Did you just round?
No, I did not. 5 divided by 2.5 is 2.